Hey, on the last lesson, we talked about 3D shapes and we talked about volume and surface area and how we can relate those things in similar 3D shapes. And in this one, we are going to start using formulas that calculate surface area and volume to find different dimensions that we might need in a 3D shape. Oops. So you should have a formula sheet in your practice. It looks like this right here on the left. And it just has a bunch of 3D shapes and a bunch of 2D shapes and some formulas. And you can see a V for volume. You can see SA for surface area. Those are things we talked about in the last lesson. And then in some of them, they have an LA. So for instance, for a cylinder, they have this LA, that's called lateral area. So that's this area not including the top and the bottom, sort of the up and down area. And so we might be given a situation here where we have a cone, which here are our formulas for cones. And we're told what the surface area is. We're told the radius of the cone, and we want to find this thing called slant height. Well, you can see in this on this formula sheet, this is like an L. Oops, that's very big. An L, that is the slant height. Height of a cone is straight up and down. Slant height is if you measured along the outside of that cone, which is kind of on a slant. So we didn't get too creative in naming that dimension. And so I know the surface area, so the formula I'm going to need is that surface area formula that you can see down in the bottom of that list of formulas right here. In order to calculate surface area, you need the radius of that circle that's on the bottom of the cone. We call that a base. And you need the slant height. Well, we know the surface area, so we're not actually trying to calculate that. We know the radius, and we want to find the slant height. So I like to go ahead and just label all the things I know from the formula. I know SA, I know R, and I'm looking for L. And remember, pi is just a number, so that's not a variable that we need to know. And then I'm going to go ahead and plug in what I know. So I'm going to plug in 99.9 for surface area. I'm going to plug in 3 everywhere I see an R for radius, and don't forget there's a squared there in the formula. And then in this next line, I'm just doing some simplifying. So 3 squared is 9. And then I'm just going to bring that 3 in front. Normally, we'll write the pi and any other variables after the number. And now I have an equation I can solve for L. I'm going to go ahead and take that 9 pi, and I'm going to move it over here. It's a positive 9 pi, and so when it comes over here, it becomes minus 9 pi. And then this 3 pi is multiplying that L, and so when I bring it over to the left, it's going to divide. And so now I have a situation where I can plug this entire thing into Desmos and get a value for my slant height. So if I type it in exactly how I see it, and when you're typing, you can go find pi in Desmos, or you can literally just type pi and it will change to the little pi symbol for you. That's sort of a shortcut if you want to just type it in there and not go find it. And when you do all that, you should get 7.6 centimeters. So my slant height for my cone is 7.6 centimeters. So I'm going to do a couple more examples with some different shapes, looking for some different dimensions. Here we have a cylinder. So we are looking at this part of the formula sheet. And specifically, we know something about the volume. So that's that first formula right there. So you can see to calculate volume, we need radius and we need height. So cylinders are built with a circle on top and a circle on the bottom, and then you kind of connect them. It's like a wrapping paper tube or from paper towels. And if you put caps on the ends, that would be a cylinder. And so we have that distance, that height between the two circles, and then we have the radius of the two circles. And so we're told the diameter. So I'm going to grab the formula I need because I know volume. I need that. I know what the volume is because we're told it's 37.7. And we're told that the diameter is 4. If we divide the diameter by 2, we'll get the radius, which is 2. So it's important that we're using radius, not diameter, but we can quickly find the radius by dividing the diameter by 2. And what I'm looking for is the height, that distance between the two circles. And so I can plug in the information I have. I'm going to plug the volume in over here. Plug my radius in. Don't forget the squared there. We can't get rid of that squared because we're going to have to actually do 2 squared. And so when I do 2 squared, I get 4, and then I like to write it at the beginning. It always looks nicer to have the number before the pi, before the h. And now this 4 pi is multiplying h, and so I need to bring it over to the other side of the equal sign. And when I do that, bring it over here, it's going to stop multiplying and it's going to divide 37.7. And now we're at a place where we can put this left side of my equation, the left side of this formula here, 37.7 divided by 4 pi. We can type that right into Desmos. And reminder that if you want to type pi, you can literally type pi, and it will turn into the pi symbol for you. And we get our height to be 3 centimeters. It's like maybe 4 or 5 zeros, so we'll just call it 3 centimeters. I'm going to do one more example here where we're given a different shape. We're given this rectangular pyramid. So there are a couple pyramids on the formula sheet. We name them based on the base, the bottom, what shape the bottom would be. So we have triangular pyramids, rectangular pyramids. We could have a hexagonal pyramid, but a rectangular pyramid down here, that would be similar to a square pyramid. A pyramid has a lateral area, which actually we're given. That's that LA right here. And that's the space here on the sides, the triangles on the sides, not the bottom. The bottom is what we would call a base. The other stuff is the lateral area. So the lateral area, you can see, is part of the surface area without this capital B base. And we'll talk more about that in the next lesson. So I'm going to go grab that formula for lateral area, and I'm going to need a slant height and a perimeter. P is perimeter of the base. So we are told the lateral area, and we are told the slant height, and we want to find P, perimeter of the base. So we want to know if we walked along the base of that rectangular pyramid, how far would we walk in yards? So again, just documenting everything I have and what I'm looking for. I have LA, I have L, and I'm looking for P. I'm going to go ahead and plug in. My lateral area is 72. L is 16. I can clean that up a little bit. I can do 1/2 times 16 and get 8. And I have one more step to solve this for P. I got to move that 8 over. Right now, 8 is multiplying P. So when I bring it to the left, it's going to divide 72. And I'm going to get that the perimeter of my base is 9 yards. So we have sort of that rectangular base of the pyramid. If I were to walk around it, if I were to walk all the way around it, I would be walking 9 yards. Now make sure you go to the practice. Make sure you're asking for help if you need it, checking your answers. And as always, take your time on this, and good luck.